On Christmas Eve, Santa will deliver presents to millions of children. But is this scientifically possible, or does he have to bend the laws of physics? Let's take a look. There are 7.24 billion people in the world. 26% are children. That's 1.88 billion children for Santa to visit, but not everyone celebrates Christmas. About 45% will be expecting a visit from Santa. That's a more manageable 846 million children. Using an average of 3.5 children per home, Santa will have 241.7 million homes to visit. With an average of 1,000 feet between houses, he will travel almost 46 million miles. That's 193 times the distance to the moon. And he will have 31 hours to do all this, owing to the rotation of Earth. To make it possible, he'll travel about 412 miles per second, 1,900 times the speed of sound. If that seems difficult, consider his sleigh. Unless he has a portal gun, he'll have all the presents on board. At 2.2 pounds per present, his sleigh will weigh almost 844,000 tons, almost the mass of the Golden Gate Bridge. Probably too much for his 9 reindeer to handle. He will also climb up and down every chimney, equivalent of 273,000 Mount Everests. And he'll be treated to brandy and mince pies at each home. He'll drink 2 3/4 Olympic swimming pools worth of brandy and eat 85,000 tons of mince pies. His reindeer will eat 61,000 tons of carrots. The sleigh itself poses a problem though. At a speed of 412 miles per second and a mass of presents of 844,000 tons, he'll have a huge amount of momentum. The impact of hitting the first house with all the presents on board will release 186 million trillion joules of kinetic energy. The last house, once all but the last of the presents are gone, will be 767 billion joules of kinetic energy. In total, he'll cause the equivalent of 41,000 dinosaur-killing asteroid impacts. That's roughly comparable to the moon hitting Earth. So you'd better watch out when Santa comes to town, because unless he's developed time travel, it could be the end of the world.